I wanted to talk a little bit about simple tips for tuning SQL queries, then what are NoSQL databases, little bit also brief about how SQL database works, and then I've marked case studies and discussions is completed because I think we've covered enough of real life scenarios, or we've designed enough of databases. That much is enough. You can work on your beyond that point. It's what I feel. So today's one will be mostly theory heavy, not much related to what do you say working in MySQL, but it will mostly be like a different set of topics. These are also like most of the times asked in interviews and all. When you're talking about databases, these questions are asked in interviews and all. So we'll try to cover those kind of things today. Okay. So I'll just cover what is 3NF and BCNF, voice code normalization form. Then we'll go to the next topics. Okay. So what is 3NF form? So yesterday we discussed about 1NF and 2NF. So what was 1NF and 2NF? One first normalization form and second normalization form. So in first normalization form, the condition was that multi-valued attributes should always be in different rows. Multi-valued attributes should always be in different rows. Okay, so this was one. This was for what was first normalization form. So for like example, when we had a table, and let's say we had user and we had his address. So we cannot group 2-3 addresses in one. It doesn't make a good database design. So what we are supposed to do is we are supposed to break it down and create 2 columns for that, 2 rows for that specific user. So this was first normalization form. Okay. Then we looked at what is second normalization form. So what was the second normalization form? In second normalization form, let's assume you had a table. If I take for example, say there's a table, and the table, let's say, had a student, and let's say he had teacher, say he had subject. So this is a table, let's say, to say which teacher is assigned. Let's say we have a mentorship between teacher and students, and say which teacher is assigned to a student. Okay, and we also say what subject this teacher teaches. Okay, so student teacher mentorship table. So in this table, the primary key becomes student, a combination of student and teacher. So if I say PK, it's combination of student and teacher. Okay, but if you say subject, subject is, it has got nothing to do with student. Subject is a combination of, subject depends on teacher. So what was happening? Subject was dependent on a subset of this whole primary key. It was not actually dependent on the whole primary key. So it was just a subset of the primary key, which the subject field, a non primary attribute and a non-unique attribute, was part of the table, and it was belonging on a subset of the whole primary key. So then what we had to do was I would create 2 separate tables. So one table which is only for student teacher, and another table which is specifically for teacher and what subject they teach. Teacher and then subject. So this was second normal form. Okay. So now we move to the next one, that is called as third normal form, 3NF. Okay. So what is 3NF? So the first condition for a table to be 3NF is that it should be 2NF. Okay. And the next condition, what it says is that, so all the keys, all the non-primary keys, right? I mean, non-primary attributes, and which are not unique also, should only depend on the primary key. Okay. So if they're not depending on a primary key, it means that they're not in 3NF. Okay. So if I was supposed to give an example, I have the examples in the PPT. Let me just copy one. So it is, a table is in 3NF if it is in 2NF and all the attributes are determined only by its candidate keys. Okay, and not by any non-prime attributes. So prime here means primary keys. Candidates keys are any of the primary keys. Okay. So here, if I take this example, so this is a table to say borrowed books. This is a table for borrowed books. Okay. So here, what becomes the primary key? The primary key becomes the book. So book is the primary key here, saying let's say the if I wanted to find out who borrowed book B1, so I would say find where the primary key is B1. So that is fine. So book B1 is there, and then who has borrowed it? There is a pattern for it, and that address is also there. Address is for the pattern, and due date is there. Okay. So here primary key is what? Book is the primary key. But if you see, this address is for whom? This address is for this pattern, right? So what is happening is a non-primary key value, this value is actually dependent on a non-primary attribute. Sorry, a normal value, a normal attribute is dependent on a non-primary attribute. So this is a primary key here, but patron is not a primary key, but I have some other value in the middle which is dependent on patron, right? So what happens then? It means that the table is not in 3NF. So then how will I convert this into 3NF? I'll group this into two different, two different tables. Where should we, yeah. So book number, patron and due. So this is belonging to one. And the address was not actually dependent on the primary key in this table, that is book number. So we create a separate table for book number and patron and address. Okay, so this is 3NF. Okay, so this is another example. So this is a table to find out who was the tournament winner in a year. Okay. So if I was going to find out who was the tournament winner in a particular year, so what will be my primary key here? It's tournament, comma year, right? So if I wanted to select, let's say Cleveland Open happens every year. So if I wanted to find out who was the winner for this particular year, so there, how would I select this? The primary key would become tour, comma year. Okay, so this is fine, tour, comma year, and I have winner. But there is also a field called date of birth. And this date of birth, does it depend on the primary key? No, right? It doesn't depend on the primary key. It depends on some other attribute which is not a primary key at all. So here also what can be done is, so you separate out this table into two different tables. So you have one table which is saying tournament year and winner, because these are all related and these are the primary keys for this table. And here another table where the person is the primary key, winner, and then date of birth. Not winner, you name it person or player. Okay, so that would look like, where is the people? No, okay, it is not given. So I'm not. So it will be similar to. So this will become one table because it is same. The other table will be, this will be the second table. Okay, so now these are in 3NF. Cool. Let's go to the next topic, that is BCNF. So BCNF is it is next version of 3NF. You can say it is a stricter version of 3NF. So for a table to be in BCNF, there are certain criteria. So what that criteria says is, if there is so let's say in a table we have a primary key, okay, and there are non-primary attributes. By non-primary, I mean they depend on somebody. Okay, they depend on this value. But if there is also a reverse dependency, right, that some part of primary key is also dependent on this non-primary key, then we say it is not in Boy's code normal form. Okay, I was going to give an example. Okay, I've taken this from Java T point. So if you see here, right, we have employee ID, employee. I'll take this photo. For a while. So here, can I say these things? So the combination here is employee ID, employee country depends on employee ID. EMP ID is deciding what is the EMP country. And then department type. Department is deciding what is the department type. And then department number. So here what was happening was, if you see, right, the unique value here, that is primary key, is a combination of the employee ID and the employee department. That's why you can see, right? So there are two values here. Okay. So the common candidate key, that is primary key, becomes employee ID, and then you have an employee department. But as you see here, the values here, no, employee, country, and department number, they're not fully dependent on this. So to make it in Boyce code normal form, what we do is we also separate out these values. Okay. So when we separate it out, it becomes this way. Now here, if you see all whatever is the, for first table, the candidate key becomes employee ID, and it is directly related. And for the second table also, employee department becomes the candidate key, and just for second table. And now these both are directly dependent on this. And in the third table also, the combination is itself the primary key, both of them together. Okay. So if we look at what are the advantages, so we did all this exercise so far, right? So what are the advantages of doing a normalization? Okay. So one is, it is helping us minimize all the data redundancy. So we are not copying the same data across at a lot of places. So that is reduced. And also what we are doing is the design is also improving, like, because we are not repeating the data. So in future, if you want to copy something or if you want to fetch some data, it becomes very easy. Okay. And also it enforces the concept of relational integrity. What do you mean by relational integrity? So let's say if any value changes in one table, right, it should not affect the other table. And if the primary, if a value in one table is deleted, all its foreign keys and all will get deleted in another table. So all those things are kept in mind when we are designing all these normal forms. Okay, cool. And what are disadvantages? So if you see here, what we did, we started with one basic table and then we started making it smaller. But in all the actual use cases, right, we may not actually know how to start with, how we're not actually be able to start from the requirements of the user. So we'll come all the way from what the whole database is, and then we make small tables and then we decide. But here it is the other way, right? And also there are a lot of other normalization forms as well. There is 4NF, there is 5NF and all. But what happens is, if you start breaking the database into more and more smaller tables, let's say if you want to find out some information, then you have to do joins across so many tables. So because of that, the performance degrades after some point in time. So it is not what do you say? So beyond a certain point, it doesn't make sense to do lots of normalization. Okay. And also it is very confusing as well. Confusing because the data is spread across a lot of different tables, right? So if you want to find out some value, you have to do a lot of joins, and also it becomes very difficult to look at the data. Okay. So these were the two types of database designs that are there in when you're designing MySQL. So one is bottom up. The bottom up approach was the normalization form that we saw, and top down was the ER diagram that we saw. So both have their own use cases and both have their own pros and cons. But if you consider the best way is, design from top down, and then once you have all the tables, then look at them and try to identify if they are following all these first normalization, second normalization. So that way you also get the best of the first part. That is, you don't actually start from the lowermost, but you see what is the requirement and then design all the tables. And then later on, you can improve the tables by seeing whether they are in they follow first normal form, they follow second normal form, and so on. So we'll go to the next topic, that is how MySQL internally works. So I've covered parts of this before as well, like what is a storage engine. So we look at few other uh, parts in a MySQL database. So the parts that are there are, we talked about what is storage engine. So we have few other parts as well. That is a server, you have a query optimizer, and you have a parser. Okay. So we'll talk about each of them one by one. So as we had discussed, storage engine is actually the one that is managing the data. What I mean managing the data, how to store the data, and then whenever you give some query, from where to retrieve the data, doing all the mapping of storage and retrieval. So all of that is done by the storage engine. Okay. And MySQL supports a lot of different kinds of storage engines, such as InnoDB, MyISM, memory, and there are a lot of other ones as well that we had looked. You can get it by, if you do a show storage engines, I think it should, is it SQL? If you run a command called show storage engines, show engines, it shows you all the engines that are available with MySQL server and what all can it support. You can see, right? So there are a lot of different engines that are there that are supported by MySQL, and you can use any of them. And InnoDB is a default engine. Okay. So a few points about InnoDB. So InnoDB supports auto transactions. So to support transaction, you need to support, you need to have all these 4 properties that we have discussed: ACID, atomicity, consistency, isolation, and durability. And so InnoDB in the backend stores data in different in the form of pages, and inside the, it is a page, but inside the page it is actually stored as a B tree. So B tree is binary tree. Okay, so it stores it as a binary tree, and then whenever you're retrieving the data back, you fetch it back from the binary tree and then send it. Okay. So other storage engine like MyISM, so this doesn't actually support transactions, and this is good for read intensive databases. So you will have databases which are read intensive, and you'll have databases which are both read and write intensive, and there are databases which are only write intensive. So depending on the use case, right? So for an example, a social networking site is a read intensive database. It requires a read intensive. Why read intensive? Because the number of people who are posting is very less, and the number of people who are fetching the data is very more, right? Like if you take for example Twitter, so a lot of people will only browse Twitter, but very few people actually go and make some what do you say, make some posts, right? So that is an example of a read intensive. Write intensive, you can consider, let's say you have a chat system, and in chat system you're storing all the messages. So this becomes a write intensive, right? So because people are mostly chatting always, they are reading also, but at the same time they're chatting also. So this becomes more of a write intensive database. Uh, and then there are ones which are a combination of both, equal amount of reading and equal amount of writing. Okay, so MyISM is, in such scenarios, it is a read intensive database, a read intensive storage engine. Sorry, and then you also have something called memory storage engine. So what does memory storage engine means? It means that the data is not actually stored anywhere in the here and all, right? So MyISM, InnoDB storage engine. So what happens when you actually turn off your computer? So there are 2 things, right? One is RAM, and the other is your data storage, like hard disk drives. So these storage engines, right, they store the data onto the hard disk. So they write the data onto the hard disk. But you can also have a kind of storage engine which will only write the data onto the RAM. So what this means, whenever you shut down your computer, right, all the data gets lost. So you might ask why we need this kind of a storage engine. So let us say if the data that we are fetching, if the data that we are storing is not required forever, it is only required for whenever the user is logging in. Like you might have heard session management. So what happens in session management? Whenever the user logs in, we store data related to that user. So once the user logs out, we don't need that data anymore. So that kind of use cases can have memory storage engines. Okay. Then so storage was the first part. Storage was one part, and then we have query optimizer. So what query optimizer does is, let us say whenever you type a query, right, it will not. So MySQL should know how to use this query such a way that it will get you the data as quickly as possible. Right? It is not directly executed how you give it. So what query optimizer does is it creates a execution plan. What do I mean by execution plan? It says, okay, so this is what the user is wanting. I'll check if there is any indexed row for this. So if it is indexed, I'll use the indexed row. If it is partitioned, so I'll see in which partition I'm supposed to go and use it. Okay, so it does a bunch of optimizations, and then it actually queries the storage. We don't directly query. Okay, so then you have something called as parser. So what parser does is, parser comes before query optimizer. So it's like storage is the lowest layer, then you have query optimizer, then you have a parser. So whenever you give any MySQL statements, right? So we have to check for whether the syntax is correct or no, right? So if I type some random gibberish and send it, it should not accept it and do some calculations on it. So what parser does is it checks whatever information that you're giving it in the form of a query, is it correct or no? Okay. So parser ensures that the syntax and all is correct, and then whatever variables you're referring to, they are present and all of that. So that is the job of parser. And at the top layer, you have the MySQL server. So what is server's job? Server's job is managing all the connections and then checking that whoever user is trying to authenticate or whoever user is trying to access the data, all the data that he has is all whatever he's trying to access, is it correct or no? Sorry, I don't mean correct or no. Is he having access to use all of the data or no? So all of that is managed by the server layer. Okay, and then the server communicates all the way to the storage engine. How do we optimize select queries? So whenever we were doing select, right? So we were using star for most of the time. Let's say I do select, I do use transactions example. So I do select star from accounts. So when I do select star, right, what has happened? I get all the rows, all the columns. So here there are only 2 columns, but it is fine. Let's say I have a table which has a huge number of columns, maybe 10, 15 columns. So in such cases, if you do a select star, right, what is happening? I'm fetching all the columns. So there might be cases where you don't need all the columns. You're only interested in finding data from 2 columns. So in such a scenario, what you should do is you should try to avoid star in most of the ways. Because what is happening, so it's like, if I would show it to you in a feed, so it is like, so let's say, whenever you deploy anything on cloud, right? So let's say your server, your database is in, let's say, West US. Let's take simple example. Let's say it is in Mumbai, okay? And then your CPU, I mean your application is also in Mumbai, but so this is Mumbai 2 and then Mumbai 1. So it is like, if you see all these cloud providers, right, they have data centers. So let's say the storage, the database is in Mumbai 2 and the application is in Mumbai 1. So you don't have control over this where you are putting it. You have the control over the city, but you don't have control over which data center. So now what happens? Every time you do a query, right? So the SQL server should have to send this data to you across the network. So there is some connection between application and between Mumbai 1 and Mumbai 2. There's a connection via fiber cable, but this data needs to be sent across this wire. So what is happening if you do a select star? No, so there is a lot of data that needs to be sent from the server, from MySQL to your application server. So we should always try to reduce it as much as possible. We should only try to get the information that is required. So one thing that you can do is, when you're using the select query, don't use the star symbol. Instead, use only the columns that you need. Okay, that way you can make the query a bit faster. Then when you're using from clause, right? So from mostly whenever you are using joins, so try to have the smaller table on the left side and the bigger table on the right side, and also try to use inner join. Why? Because if you use outer joins, right, maybe left outer join or right outer join, what happens is there are a lot of unnecessary rows that you don't want. So whatever is not getting matched is also coming into the table, right? So I don't want to do that. So it is better to have rows which are matching on both the sides. So that is one, and the other is use a smaller table on the left side. So what happens at that time? So let's say I use the smaller table on the left side. So there is a smaller table on the left side, and there is bigger table on the right side, and you're doing a left join. So what happens is, whenever, so you only check for these many rows, right? If there is any matching, you quickly get them. So always we should try to keep the smaller table on the left side and the bigger on the right side. And then in where clause, whatever column you are using, right? So ensure that that has to be indexed. By indexed, I mean if it is a primary key, it is anyways indexed. If it is unique, it is anyways indexed. But also, if you are accessing something else, so you should always try to index it so that the search query becomes very fast. Because if you don't index, it is like going over all the, if there are 100 rows, and if you're not indexed, no, like going over one by one, one by one, one by one, one by one, all the rows. So we don't want that because it will reduce our performance. Cool. This is one. And then whenever you're using a where clause, use indexes. And also it is better if you don't use regex operations. So like where you do like and then say dollar, and let's say I did dollar ABC and then dollar. So in this, what happens is this is very expensive query. Expensive because it tries to match all possible combinations. So it can be anything on this side, it can be anything on this side. So let's say if I have a string of size 200, A, B, A, B, A, B, 1, 2, 3, A, B, C, A, 1, 2, 3, A, B, and all like this. No, so it has to go through the whole string, read where A, B, C is there, and check if other side also that whatever I've given in this like is there on this side also. So it becomes it is slightly a bit expensive. So instead, you should try to use directly. If you know whatever is the word that you're using for a number, so use a direct word instead of doing like and all. Anywhere, not just in MySQL, anywhere regex queries are very expensive. Okay, so we should try to avoid them. So that is one thing. And use and or operators. The query becomes faster and it is not confusing. Okay, so even when you're doing order by, right, so if you say I want to order by a certain column, then you should also try to you should index that order by also, because when you're doing order by, you're actually sorting the whole table, right? So once you have done the where and all, when you're doing order by, you're actually sorting the whole table. So to sort it faster, you have to, if it is indexed, you can sort it very quickly. Okay, if it is indexed, it is sorted by default. So what, when you index, what happens is MySQL knows how to, MySQL stores it in a kind of sorted form only. So if you do ascending or descending, it will quickly be able to give back the information to you. Okay. And also, whenever you're fetching rows, don't get all the rows at a time. You can use a limit clause. So we had discussed about this, right, where you had a combination of offset and limit. So try to use those values whenever you are fetching rows from the table. Again, why? Because of the same thing that I told. So you'll have the database is somewhere. Okay, it is not coming. So the database is somewhere and your application is lying somewhere. So you don't want to waste time just getting the data. So if the user wants more data, you can request again and show to user. There is no point. Let's say you have a application and in the application there are 1 million rows. Okay. So if you get all the 1 million rows in one go, let's say it takes you 2 minutes. So instead, what you can do is fetch only 100 rows for the user. Okay, show him 100 rows, because your mobile screen or your phone screen, no, it will only be able to see 100 rows, let's assume. So there is no point in fetching 1 million rows, because he might not even scroll all the way till down. He might not even scroll all the way till down. So what you can do is, if you start scrolling a little bit down, then you fetch the next 100. If you start scrolling a little bit more down, then you fetch the next 100. Okay, so this is how, even when people implement infinite scroll, right? So there are two types of scrolling. One is infinite scroll, the other is pagination. So in pagination, you ask the user specifically which page you want to be on and what is the size of the page. In infinite scroll, what you do is, let's say if there is a phone like this and I have information. So if I realize that the user has hit the last, let's say there are 100 posts. If I say the user has hit the 80th post, then I'll request for the next 100 post. So actually in the backend, I'm calling the API and fetching few more posts, but for the user, it is like, oh, there is always some data that is always coming. Okay, so this is how people implement infinite scroll. And nobody will ever load all the 1 million rows at the same time. Why? Because 1 million rows is very huge amount of data. And then you don't want to, because to load 1 million, let's say it takes 2 minutes, no? So the user has to keep waiting. You'll see a circle screen on the user phone for 1 minute saying loading, loading, loading. So instead of that, you keep sending 100 every time, and then whenever you feel user needs more, you can just keep adding at the end. Okay. So that is why always try to use limit and offset clauses as well. Okay. Then to look at what is happening inside your query, right? So I told you when you're doing select statement or anything, no? So you have like let's select star from account. So if you want to see what all is happening, no, you can add explain in front of a query, and then if you do an enter, no, so it gives you a lot of properties. So using these properties, you can identify and see if there is anything that you can use to improve your query performance. Okay. So what all are the properties each property say? So ID doesn't matter. ID is just if you are fetching tables from two rows, it will give one ID for one single table. Okay. So then there is a select type. So if you're doing just a simple select, nothing other than from one single table, it is called simple. So here if you see the select type is simple. And then you have primary, which means you are doing a subquery, or you are doing using from clause. No, in the from not in from clause. In from clause, if you're using another table and you're doing a subquery, okay, or if you're doing a union, it says union. And then you have table name, saying which table is being accessed. You have partitions. So I'll tell you what partition says. It says how many number of partitions are being accessed, and then what is the type of access that it is using to retrieve all the rows. Okay, and then what are the possible indexes that is using for the query, and what it has actually used, and what is the length of the index that is being used. Okay, so there are a lot of other fields that you can look at, and if you want to optimize your query, you can have a look at it and try to optimize. Okay, next talk about horizontal. What is horizontal scaling and what is vertical scaling? Okay, let us begin. So let us assume. Hi Chetan.
Yes, sir.
Chetan has started a website. Let's say it is a shopping website. So Chetan, let's say he was a fast fashion brand enthusiast, and he started a shopping website. And then what happened? He got an offer to be on the Shark Tank, and when he went on Shark Tank, his shopping website exploded with lot of requests. So because he went on Shark Tank and then his show was aired, lot of people started coming and hitting your app. Okay, and let's say in the backend you're using MySQL, but let us say the size of the server you had, no, it had only, let's say, 4 cores and 8 GB of RAM, the MySQL server. So now because lot of users are hitting your service because you have become popular, so now the server is giving responses very slowly. So let's say before it was taking 40, let's say 200 milliseconds. So 1 second is 1000 milliseconds. So it was taking 200 milliseconds. Now it is taking 2 seconds because the number of users are very much. So it is like this, right? So you have a database, and there are people who are coming and standing in the line, and at a time you can only process 4 people. Now if 40 people come, if 4 people you're able to process in 2 seconds, 200 milliseconds. So now for 40 people, for the last guy, how much it will take? It will take approximately 2 seconds, because that person can be the last person, right? So on an average, it is taking two seconds for that person. So now Chetan should not lose his business, right? So what will we do in such scenario? We want to give the best user experience. Anybody wants to take a guess? Simple answer. What I'll do, I'll try to increase the size of this machine. So it only had 4 cores and it had 8 GB RAM. No, so what I'll do, I'll increase the cores to, let's say, 16 cores, and I'll make it 64 GB. Okay. Cores is just like saying how many processes can you run at the same time, and RAM can be used to store all the data in memory. Okay. So now what I do, I instead of 4 cores, 16 GB, 8 GB, I add 16 cores, and then 64 GB. 16 core CPU and the RAM is 64 GB. Okay. So now what happened? He's able to he's able to serve all the requests properly. So now people are again happy. But what happens? So his startup becomes very, very famous that it gets featured by Narendra Modi in Man Ki Baat. So before, if you see, no, before Shark Tank, every day, every minute he was getting 100 users. Okay. After Shark Tank, what happened was every minute he started getting 10,000 users. So now his website has become even more popular. So now every minute he's getting 1 lakh users. So now what is happening? Even this, whatever he increased the size, right? It is not helpful. So what can you do now?
Increase number of servers.
Yeah, so he can increase the number of servers, or what he can do, he can see, he can think, okay, 16 cores, I'll go for even bigger machine. So what I'll do, I'll put a machine with 500 cores, okay, and then the RAM will be 8 TB, 1964 GB. The RAM will become 8 TB. So I have this much RAM and these many cores. So now what happens? Now his website is able to serve all the 1 lakh users. But now again, what happens? Barack Obama also sees that this is very good and he also promotes it. Then again, users come to your website. But now what happens? You cannot increase the size anymore, right? You cannot increase the size anymore because the best machine in the world only has 500 cores. You cannot make a machine which is bigger than 500 cores. Okay, and there's the only limit. So now what you will see, okay, I had one such machine of 500 crore, I can add two such machines of 500 crore. So now it is like, instead of making this size, so I had one this size of machine. So what I did, I purchased a new machine of this size. So instead of doing this, what I'll do is, I had one before, so now I'll have two before, two like this. So I have four like this. Okay. So you see what is happening? So there is a limit in making this one single machine how much or big I want. But I can take this same size machine, I can take 100, I can take 1,000. So these are two types of ways in which we can scale our system. What do I mean by scaling our system? We can increase the number of users that can access the database, or we can increase the number of queries that we can run on the database. Okay, so there is a metric called as QPS. QPS stands for queries per second. So if we scale the system now, so the QPS will increase. Okay, QPS will increase because there are a lot of users. Our size of the database is big, and as many users can come and access our database. So we are not actually harming the performance of the system. So this is one thing. So what we did here, right, in the first case, where we're increasing the size vertically, where we're growing one single database. Sorry, we're growing one single database. So this kind of growth is called as vertical scaling. Okay. And the second one, where we were actually making, we are not actually growing one single machine into bigger and bigger. We are buying similar such small size machines and we're connecting all of them together. Now, because of this, what happened? We were able to serve user request, and this kind of scaling is called horizontal scaling. So one is vertical scaling and one is horizontal scaling. So there are pros and cons of each type of scaling. So we'll discuss about what these are. So discuss what is scaling. If you want to increase the capacity of a system, then we call it scaling, and we can scale our system in two ways. One is horizontal scaling and one is vertical scaling. And this is not just for databases, even for computers. By compute, I mean CPU. So here I was talking about database. Actually, databases are also hosted on computers only somewhere, right? But let's say if you wanted to scale your computation capacity, so then also there are two calls. Anywhere in tech, if you want to scale, right, you can scale horizontally or you can scale vertically. So in vertical scaling, what we do, we try to add more resources to a single server. So that way, what we are doing, we are increasing the size of one single resource only. Okay. So what all can we add? We can add the CPU size. We can increase it. We can add more number of cores. We can increase the amount of RAM that a system has, and we can increase the storage. Okay. But what is the issue with this kind of a system? The issue is that it is limited. So you cannot keep adding more and more RAMs to a single machine. At one point, what will happen is you'll end up adding so much that you can't add anymore at all, right? So that is the issue with vertical scaling. And vertical scaling is also very costly. Why is it costly? Because let's say if I wanted to buy two such systems, right, this is 100 rupees. So this will be 200 rupees. This is 100 and this is 100. So both together will cost me 200. But a bigger system, no, it is very difficult to make, and as the system grows and grows, right? So this might be costly. It might cost me 250 rupees or 300 rupees, right? So it is also, it makes sense in a business term, because you can buy same set of hardware as many as you want. So these are called as commodity hardwares. Commodity because it is very easily available, right? So that is why it's called a commodity. Whereas if you want to get bigger and bigger systems, it becomes very costly also. So that is another reason of why you would want to use horizontal scaling or vertical scaling, because it is very cheap. Horizontal scaling is cheap, whereas vertical scaling is costly. Okay, so it can become expensive. And then in horizontal scaling, what you do, you actually distribute your data across different servers, and that is why it becomes very easy to handle large load and also distribute all your data. Okay, so horizontal scaling becomes cost effective. But yeah, I think we discovered this, no? So for a database, right, what are the problems that you can think when you are doing vertical scaling versus horizontal scaling? So, so let's say I had so this is horizontal scaling and this is vertical scaling. So in horizontal scaling, if I wanted to increase the size, what I'll do like this. So now what happened? The data is stored across different servers. So now let's say they are connected by a network, right? So they're connected by network, and in vertical scaling, there is only one single big machine. So now let us say I want to do joins. Okay, so I want to do joins. So will it be easier on this or it will be easier on this?
Vertical scaling.
Vertical.
Yeah, so it will be much easier to do a join on this system. Why? Because all the data is stored in one database only. Here, one single database. But here, what is happening? So the data is spread across lot of different servers. So now, if I had to do a join, no, so I have to go run this join query on this table, run join query on this table, run it on this table, run it on this table, and there should be some common point where I get all this data together, and then I combine them and then send it back to the user, right? So join becomes very expensive when you're doing it in a horizontal table. Okay. And let's also talk about transactions. So even for transactions, which is in on which side is it much easier to do a transaction? Yeah, it's again vertical. So even if you want to do a transaction, right? So it is very easy to do it on a vertical because there is only one single machine. So everything you want to do is available at one place only. But here what happened? So let's say I wanted to do a transaction for two different tables. So one was accounts table and one was loans table. So accounts table was in this server and loans table was in this server. Same database, but different servers. So let's say I modified the data on accounts table. Then what happened? There was a rat. It came and it bit the wire. It ate the cable in between here. So now there is no way for this server to know whether the transaction actually succeeded or no, because it is not connected to the internet only now. Because what happened? There was some rat in the data center and the rat came and ate the wire. So now what should it do? Does it assume that the transaction is completed or it should discard it? What should it do? But it has started the table where loans were there, no? So loans has actually completed updating the data and it is saying transaction is completed. So it is persisting, but this doesn't have any access only. This doesn't have access to the internet only now because its wire has been cut. So ideally it should try to do a discard, right? Because it doesn't know whether the transaction is completed or no. Right? So similarly, there are a lot of issues that come up when you're using a horizontal scale system. Why? Because there are a lot of possibilities. So at any time, one of this can go down. Let's say there was a power. So these four are in different data centers, and in one data center, tsunami happened. Okay, and because of that, this server is down. So now what happens? This cannot participate in the, let's say when somebody is trying to do a get or when somebody is trying to do update and all. So from this you're not getting anything. So that is bad, right? That should not happen. Let's say, and because of some reason, the data in all of these is not consistent. So because one was turned off for a while or one did not get all the notifications properly, so the data in this can be inconsistent. Right? So all of this can happen with a horizontally scaled system. But whereas in a vertical scaling, it is either 0 or 1. It either happened or it didn't happen. So there are different use cases of when you would want to use a horizontally scalable system and when you want to use a vertically scalable system. But MySQL, we only do, most of the times we only do vertical scaling. Mostly RDBMSs, right? Relational database management systems, we do vertical scaling, and NoSQL databases, we do horizontal scaling. Okay, I'll come to why we do horizontal scaling in NoSQL and why we do vertical scaling in relational databases. But for your understanding, just identify, keep in mind that horizontal scaling is ideal for NoSQL databases, whereas vertical scaling is ideal for SQL databases. Okay, so why you would ask that question? So what is the speciality of a RDBMS, relational database? It supports transactions, right? Most of the MySQL also, they support transaction, correct? And they support very fast joins. So for a join, if you wanted to do a join in this horizontal system, it is possible. I'm not saying it is not possible. It is possible, but it is very time consuming. And also these are not well very good for transaction, because there can be a lot of scenarios where the system, one of the nodes which is participating in the whole database goes down. This can go down, this can go down, this can go down, or there might be some internet connectivity issue because of which they're not able to talk to each other. So that is why horizontal scalable system databases are not actually suited for transactions and all. That is why MySQL, which is a relational database, we try to scale it vertically. Cool. But still there is a way by which you can actually scale relational databases also, and that is called as partitioning. So I'll tell what partitioning also is in a while. Cool. So you guys understood what vertical scaling is. You increase the amount of RAM, storage, and CPU that you give to a system. And in horizontal scaling, what you do is you actually replicate the whole database. Not replicate. You actually pick up one similar machine like this, and then you copy it and paste it. You buy same random hardware, and then you're using them. Okay. So this is what is horizontal scaling, and it is cost effective. Plus, it can handle a large amount of traffic as well. Cool. So next, let us talk about sharding. What do you mean by sharding? So let us say I have a table and I have user and I have lot of information and I have country. So country is India, there is US, there is Mexico, there is Egypt, there is Pakistan, and so on. So, and I have seen that most of the times, right? So if somebody's country is India, no, they'll only access the data in India. They don't usually come to US and then access the data. Right? So does it make sense for me to have one? There is actually on the top, it looks like it is a single database only, but in the back end, I'll have one small part of the database for India, one small part of the database for USA, and I'll have one small part of the database for Europe, and similarly for other countries. So this makes much more sense, right? Because all the users who are in India will always try to access the data from this table, and all the users who are in USA will always try to access the data from this table. Europe will try to access from this table. So by dividing them into different groups, what we are doing is, one is latency is reduced. Latency means how much time it is taking for a user uh, to talk to the server and come back. So if you would have played PUBG, you see ping, right? So ping is this much second, this much second. So that is nothing but latency. So the lower the ping, the faster you can play properly, right? It is because the faster you are able to send data to the server and get back the data. So that is why if the data is situated geographically very close to you, the latency will reduce. And also, the database does not grow in size. Let's say if I had 1 million users, so now the users are distributed across different countries. So my database is also not big in size. So what are we doing here? We are breaking the database into smaller chunks based on certain property, or let's say based on certain key. Let's call it a key. Okay. So based on certain key, we are breaking the database into smaller mini partitions. Okay. So this kind of exercise is called as sharding. So what we are doing, we are actually grouping the grouping the rows in some logical sense, and then we are making them into smaller databases. Okay, but to actually from external point of view, it will still be a same database, but internally you can say there are ways by which you can shard, or you can break the database into smaller groups and store it. It is not just used in it is a way to do horizontal scaling. Why horizontal scaling? Because now you have 2-3 small systems, right? Instead of having one big system, you have 2-3 small systems. Okay. So here data is divided. So it helps for better performance and scalability in very large databases. So in sharding, right, there are different ways by which, okay, I have not specified that topic here. Okay. I think I have a different few more slides for sharding specifically. But here, if you try to know what is sharding, we are just breaking the whole database into smaller groups, so it is easier for us to distribute all the requests that are coming into the database. Okay, and then okay, the property of consistency and availability. So in horizontal scaling versus vertical scaling, right? Okay, I'm not able to get back. So in vertical scaling, you have one single dabba, and in horizontal scaling, you have many similar like this. One here, one here. Okay. So, and all of these are connected. So because all of these are connected, and then the data is stored across different servers. So let us say a request comes in. So there are 25 users in this, 25 users in this, 25 users in this, 25 users in this. Okay. So even if one of the databases goes down, still 75 users will be able to access the data, correct or no? Yes, right? So my availability of the system is still 75%. Okay. But let us say this also goes down, then it is still 50%. This also goes down, it is still 25%, right? So even if one of the system is going through a failure, we are able to access other parts of the system because those are still active. So that way what is happening? Availability is increasing. Okay, but here all the 100 users are in one single database. Let's say this goes down, then what happens? No one can use it. So that is why horizontal systems, horizontally scalable databases are much available. Okay, so they are always available, and then vertical scalable systems are not always available. Not saying not always available. The problem here is there is higher chance of failure than here, because if this goes down, everything goes down. But here, if one of them goes down, no, you can still access the other ones. Correct, right? And if we talk about consistency in such scenarios, no. So let's say 25. So which service do you think which kind of system do you think will have better consistency? The horizontally scalable one or the vertically scalable one? We discussed the same thing. Well, let's say I'm doing a transaction, and the transaction is supposed to talk to all the 4 systems. By system, I mean databases here. Okay, sometimes I'm using the word synonymously. By system, it is a database. So if I'm doing a transaction, then across all these 4 databases, if I have to persist the data, no, it can happen. It is persisted onto 2, the other 2 is not persisted. So what happens then? The data goes into an inconsistent state. But in vertical systems, it is always like what do you say? It is more consistent actually because it is on a single server. You know whether you have done it or you're not done it. Here you don't have to talk across 3, 4 servers to identify whether some action or some transaction is completed or not. Okay, so that is why horizontal systems are more available, whereas vertical systems are more consistent. Okay, so that is what when it comes to consistency and availability. So horizontal scaling consistency becomes a challenge, but high availability is failure in one service. I think I'm talking this with respect to MySQL, but high availability becomes a problem in. No, wait. No, it is fine. I think this is wrong. So these are considered highly available because at least some of them are active. And here, if one of them goes down, it will always go down. Okay. So we discussed what is vertical, horizontal. So let us talk about what is sharding. Okay. So I just showed you a bit, but we'll try to take 10-15 minutes and cover what sharding is. Okay. So you might have heard uh, hashing. Do you people know what hashing is? How many of you know? If you guys know what hashing is. Okay. So I'll just explain uh, briefly what hashing is. Okay. Let's say you have so let's say you have a function, and then inside this function you pass some value, and outside of this function you'll get some other value. Put it in a box. You get some other. Let's say I have IP, and then you get OP. So fn of IP will give you OP. Okay, and this is always true. So at any time if you put this value inside this function, no, it will always give you OP, and it will always be same. Like if I put function of 1, no, if it is returning me 2, it will always be 2. It is not like today it will give me 2, tomorrow it will give me 3. It will always be the same. Okay, and it will give different values for different numbers if I pass it inside. So basically what it does is it takes certain set of values. Let's say I have 100 values, and then I group them into 10 different values. 10 different, I wouldn't call value, I'll call them buckets. So like this, I put them into 10 different buckets. So now I send any item from this into this function. What it does is it maps them to one of these buckets. Okay. So this way, what I'm doing, let's say if I'm getting a request from some user, from these 100 users, and when I put them into this function now, I'll get to know in which bucket they are belonging. So I'll go to that bucket only and do any modification and all that I want. Okay, like for example, let's say the function is a very simple function, that is the function is whatever you put inside, it will do mod 10 and give you. Okay, and the buckets are okay, not mod 10. So let's say I have 4 buckets. So the function is anything you give to it, it will do a mod 4 and give it to you. Okay, let's say I sent 1 into this function. 1 mod 4 is 1, so it tells go to this. Let's say this bucket is called 0 bucket, 1 bucket, 2 bucket, 3 bucket. So if I send 1, it will tell go to this bucket. Let's say if I send 11, 11 mod 4 is what? 11 mod 4 is 4 to the 8, 3. So it will tell me go to this bucket. So 11 is here, 1 is here. Let's say I send it 31, 32. So 32 mod 4 is what? 0. So it tells me go to this bucket. So 32 is stored here. So this way what I'm doing, I'm consistently taking all the inputs that I'm getting and I'm distributing them across certain groups. Okay. So this kind of a function which is used to distribute this, no, this is called as a hash function. Okay. So what we're doing, we are sharding the database using hash functions. Basically a simple idea where we want to group, let's say I have 1,000 rows in my DB. I want to group 1,000 rows into 10 different boxes so that each small box will only have 100. So it becomes very easy for me to fetch from the 100 instead of fetching from the 1,000, right? And it also becomes very easy to query also. So let's say if I want to find where is 64, so I don't have to search about in all this. If it was not a box, it would have been one single box. I'd have to go search for all of them. Instead, it will become now 64 mod 4 is what? 0. So I'd only go search in this box. I don't have to search in all these three boxes. So it also improves the search time because all the values that we're adding are hashed. Okay. So in sharding, you can use a hash function and shard it, or you can shard based on range. A range can be, let's say I have names A, B, C, D, E, F, G. So anybody whose name starts with A, put them in A box. Box, I mean smaller database, okay? Partition. So anybody whose name starts in B, put them in B partition. Anybody whose name starts with C, put them in C partition. So this is another example of doing a sharding. So this kind of sharding is called range partitions. Okay. So you are partitioning the groups on the basis of a range. You give it a range, and then for that range, it will do a separate group. So one is range and one is hash. So hash-based partitioning and range-based partitioning. Okay. Cool. I think that is only the technique used to split. So when do you actually need sharding? When the data is growing too huge, and then you have a lot of reads and writes on your service, and you also want your system to be highly available, and if you want to distribute data across a lot of places. Okay, so these are all the times when you would want to use sharding. And in sharding, what we are doing is we are partitioning the data, and we use certain value by which we decide in which group it belongs to. Like here, the first letter of the name was the value, so this is called as the key. This is the sharding key, and then you distribute the data across different servers. Horizontal partitioning. This is not. So we discussed about what is hash-based sharding. Horizontal partitioning, vertical partitioning. Horizontal is you distribute it based on the rows that you're getting. Vertical is you directly put different columns into different databases. That can also be one approach. We looked at this. It's already done. Partition by range, partition by hash. Partitional partitioning is you create tables only with different columns. Hash-based sharding. This is done. Okay. So basically, this is what is an overall idea about what sharding is. Okay. So we'll go next to what are NoSQL databases. So what is a NoSQL database? So NoSQL actually stands for no SQL. Sorry, not only SQL. It is not just SQL. It is more than SQL. You can say like that. Okay. So why these are used? Initially, we only had relational databases. Okay. So NoSQL databases were also there, but they were not popular. They became popular around 2000, after 2000 only. So before that, nobody used to use NoSQL. Everybody was using relational databases only. And even to date, I'm not saying we should use NoSQL. The relational databases are still used. Or they are used at most of places because they have been there since what 50, 60, not yet 50, 60. I would consider 50, 60 years. From the beginning, we have been using relational databases and they have stood the test of times. Whatever we do in relational databases, there is support for. Matlab, people have done a lot of use cases with relational database. So if you want to do anything, people have done it in the past, so you can easily replicate it. So why do we still need NoSQL then? Okay. So one is the data that is stored in NoSQL is unstructured. Okay. So what do I mean by unstructured? If you look at the databases that we are using, right? So there we always had to define a query, define a definition for our table. So if I wanted to create a table, sorry, yeah. So I had to say table, and then in the table I had to define, okay, these are the four columns. Student will have an ID, he'll have a name, he'll have a roll number, he'll have a date of birth. Okay, so this is fine. So this is okay for a student. So we are using a relational database. But let us say I go to Amazon. Okay. So I go to Amazon, then I'll take a look at one product. Okay. Let's say I open Amazon.in. So if you see how many categories of products we have, right? So if you say, let's say I have, you have music instruments, you have flights booking, you would have, what do you say, home appliances, you will have electronic accessories, you'll have daily essentials, you'll have fashion items, you'll have lots and lots of different types of items. So do you think if I create one, let's say I would have one table called as product, and I'll make one single table for it. Then if I'm making one single product table, and then let's say I want to put clothes in it, I want to put music items in it, and I want to put groceries in it. Okay, so clothes have different properties, right? So like, say it's a product name, they have the category. Okay, so everybody will have a price. Let's say everybody has a price. Everybody will have a manufacture date when it was produced, but cloth will have size, cloth will have color. Music items, let's say earphone, it has decibel. Music item may have does it support noise cancellation, and groceries will have freshness, or let's say it will have some other properties. Okay, so now if you see, if I'm adding a cloth, right, this doesn't make sense to me. Decibel, noise, what is its battery? I can add what would you call it? Battery life. So music items, let's say earphone and all, they'll have battery life. But clothes won't have battery life. Groceries won't have battery life. So what is happening? We have the kind of the products are same, but the needs are ever changing. By what do I mean by ever changing? So let us say I had so like if I would add product here, right? So there are a lot of rows which are left empty. So the structure is not well defined. Correct? Can I say that the structure is not always well defined for items that are that maybe belong to the same category, but they're not actually, they're slightly different. So the structure is not well defined here. And also think how is adding a new column to a table. Okay. So like take for example, I had clothes, and basically all clothes will have let's say size, and let's say they have color, and let's say they have quality. I mean, is it nylon, is it plastic, is it cotton, is it something like that? Okay, quality. Okay, but what happened is a special kind of cloth came, which also had an extra property. Let us say it had a property called color changing. Okay, so we'll have does color change. I keep watching a lot of Shark Tank, so I get Shark Tank references a lot. People, if you have seen, Girgit was kind of a company that came in. They had color changing clothes, right? So let's say you have color change. Does color change? You have property. So now this color change property is false for most of them. Agreed. It is false for most of them because only one product was there which had color change capacity, color as what do you say? So only for one of them it will be true, right? So now for all these places, I filled what I filled false, 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 false. So does it make sense? I'm wasting all of this much space, right? So let us say something else comes up. I have electronic gadgets, and electronic gadgets know the speed at which they are progressing. So you get one or new property every few days for different types of devices. So let's say there was I have laptops. A few years back, people wouldn't have thought, okay, I'll have laptops which are convertibles. Like let's say a laptop only converts into a tablet. Okay. So if I would have designed the database, let's say in 2012, I wouldn't have had a laptop which would have been convertible, even if we had, but let's assume we didn't have it. So then there came a request saying there are convertible laptops. So I allowed to add a new column, convertible laptop. So after some years, GPU started coming. So let's say I add one more new table for GPU. Then what happened? Now laptops also come with SIM. So I'll add one more table, does support SIM. Okay. So like this, if you see what is happening, my requirement is growing or my requirement is changing very often, right? So since the requirement is changing very often, MySQL or relational databases are not meant for handling this kind of a requirement. What will happen is you will add a lot of columns for them. Then what happens? There are a lot of columns which are empty, which doesn't make any sense. So that is why we say NoSQL databases support for unstructured or semi-structured requirements. So like in what do you say, in shopping websites, or let's say you have hotels, or let's say you have room booking and all. Room booking also can be structurized, but you'll have a lot of extra features or things anywhere where things keep changing very fast, right? So it is very difficult to have a table for them and then put all of them in that specific table. Just likely in case of banks and all, no, it is banks and all, they need relational because they need transactions and all. There some parts of it you can fit it in a relational database, but still there are a lot of places where you cannot be able to fit the whole database into a relational format. Okay, in such places you can use NoSQL databases. Okay, so NoSQL databases do not have a concept of these are the rows, these are all the rows for a particular table. So in that, what you do is you can insert data as a JSON file. So it's like a JSON object. So if you have seen what is a JSON object is, like you have the file name insert.json, and then you have a flower bracket open, flower bracket close. In this, you have a lot of different. You have a property, and then you have a value for it. Okay, so NoSQL databases are, they store data in JSON format, or let's say some other format, but not in relational table and all. Okay, so why? Because they are semi-structured. So you can add any for only one specific item in the database, right? You can add one single column saying, okay, so this property for this particular item only. You can say that. Okay. So no fixed schema is one, and they are highly scalable. So why they are highly scalable? Because we NoSQL databases, they don't support transactions. Very few of them. None of them support, I think, even if there are very, very hand few of them. So because they don't support transactions and all, they are mostly focused on availability. Okay. So because they're focused on availability, they can do horizontal scaling. So it is easily available and it is very available. So if you take, for example, these social networking sites, right? If you take Instagram, or if you take Twitter, so they'll be using, or even YouTube, they'll be using NoSQL databases, because the requirement or use case is not necessary that they have to be consistent always. It is not like you lose some money, or customers will come and ask you questions if the likes on a particular post is not in sync. That is why you see somebody will see 100 likes on your post and you may see 95 likes. But if you refresh it after 2-3 hours, all the likes will be same. So these are kind of systems where you don't need consistency. You don't need there's some field, there's some so you can be satisfied with eventual consistency. What is called as eventual consistency means the systems are not consistent now, but after some point in time they will become consistent. They'll sync with themselves and all, and it becomes consistent. So uh, NoSQL databases mostly have eventual consistency concept. Okay, but you can have what do you say, real time consistency, but for then you lose something else. So we'll discuss what is that. And NoSQL databases have distributed architecture. Distributed because it is whenever you have this 4455 boxes, right? So it becomes distributed. And there are different types of NoSQL databases. You have document databases, key value stores, column family, graph databases. A document can be like, MongoDB is document based. Key value, Redis is key value. Azure Tables is column family. Graph, I think I'm not sure. NeoJ, there is a database, I think. So graph data. There are different types of NoSQL databases. Okay. And we discussed the use case. So for web applications, because no, they need to be highly scalable, because let's say there are a lot of people who are hitting your service at the same time. You can only grow so much vertically. Beyond a certain point, cannot grow vertically, right? So then you have to look at horizontal scalability. and NoSQL databases are very good at scaling horizontally. So that is why they are used for web applications. They're also used for big data. Why big data? Because big data is not real time, right? So it is used for doing queries, or it is used for generating reports, or it is used for doing analysis and all. So even here, the kind of data that comes is very unstructured because you are collecting data from a lot of places. The data is very unstructured, and because of that, NoSQL databases make a good use case here as well. Real-time analytics, IoT, same reason, because it is not structured and they are highly available, and you can process a lot of requests at the same time. We use NoSQL databases. Okay. Advantages, I think we talked about it. Highly scalable, flexible, availability is high, distributed architecture. What are the disadvantages? So we talked about all the advantages of NoSQL. What are its disadvantages? So the disadvantages being, one is it doesn't understand structured query language. So whatever we studied so far in last 17 classes doesn't apply. So select statement, select from or where and all, no, this kind of. So NoSQL databases don't support SQL. So they have their, most of the people have their own query languages. It is slightly different, but the idea remains the same. You'll have something similar to where, from, and all, but it is not a direct correlation of SQL only. Different people use different languages to support talking to their databases. Okay, and query, because same query SQL same, and very less transaction support as well. They don't support transactions. Okay, cool. So examples, you would have heard a lot about MongoDB. Cassandra is also there, and then you have Redis and Neo4j. So what do we understand from this? One is NoSQL databases are used for handling large volumes of unstructured data, and also they scale very well, and they are designed for very high availability. And but it is again, the use case depends on whatever are the requirements. Or at lot of places you can see, for some places, for some reasons they use SQL, MySQL and all, but for some other places they'll use a NoSQL database in the same company. So in the same company, if you're storing employee details are very like a user detail. It's very common, right? What you'll have name, you'll have email, you'll have phone number, you'll have address and all. So these are very, you always know what all you need here. So that can be in a SQL database, so that the queries are very fast. And in NoSQL database, you can store other data like what is your favorite color, what is your favorite picnic spot, or those kind of references. They can store it in a NoSQL database. Cool. And if we see what are the differences between SQL and NoSQL, SQL is relational, NoSQL is non-relational. SQL databases have a fixed structure, NoSQL databases have dynamic structure, and these SQL databases are best suited for, not suited for hierarchical. They are row level and all. NoSQL are for hierarchical. Databases are for complex queries. Joins and all actually don't work well in NoSQL databases. And SQL databases support ACID properties. NoSQL follow CAP theorem. I'll tell what CAP is. And there are certain examples. Okay. I think that's it. Next is we'll learn what is CAP theorem. I'll stop here for a while if people have any doubts or anything.
Guru,
Yeah, tell me. Sir.
can you show some unstructured or semi-structured data example?
Yeah. Let's say um, I was to open. Yeah. Say so you should take, so JSON looks something like this. Okay, so these are different values. So this is one single database. So inside this database, this person has added, there is a ID and then there is a book ID rating count. If I take one more, it looks something like this. This is how a JSON looks like. And then let's say for a specific book, if I wanted to add, oh, sorry. One second. Pressed wrong. Shift tab, no? Shift tab, yeah. So let's say if I want to add one more property, I can come here and add like this. Whatever is this, and then so it is not necessary that all of the values should have a property. You can skip it. Powers, what all is there? Take one. So he has a ID, title, page, thumbnail, long description. But if you see it does not put like a table row thing, right? It's like a JSON, it's like a file. It's one JSON, it's one text file in which all of this is stored. And then if you want to add any extra properties, you can add it here only. Not necessary that it has to be added for all of these. Okay.
Okay. So that means this is a semi-structured or unstructured?
This is, you can consider it as this is still semi-structured, I would say.
Hmm.
Unstructured, so if you take Redis and all, right, so there you can add anything that you want. It is key value pairs.
Okay, okay.
I can only take, so I say title and I say I put this, or I put some JSON inside, or it's like a dictionary.
Okay. The
Okay,
value type will be different, right?
yeah. So the value
Oh,
type can be anything. Yeah, correct.
okay, okay.
There it becomes totally unstructured. So this is still semi-structured because you have at least some that are consistent across, right?
Yes, same data type kind of thing.
Yeah, correct. But the advantage here is you can add any number of extra uh, fields that you want, but it will be only for whichever rows that you added. The other ones it will be null. Nothing will be there. Okay, but whereas if you'd want to modify a table, right, then you would have to create a new column, and then that column will be present. It will actually store certain data for that column everywhere for all the rows. And then if you have some constraints and all, so the number of columns in your database will keep increasing long because different items in the same table might have different properties. But just how we talked about this shopping website, right? Or clothes only. All of them are cloth items, but different cloth items may have different properties. So it is very difficult to model them in a entity relation diagram or in a nor proper schema. So that is why we call that it is unstructured.
Yes. Okay, okay.
Okay, cool. So we have what is CAPTHEL. Okay, so how ACID used to stand for, what does ACID stand for?
Atomicity, consistency,
Consistency.
Isolation and
durability.
durability. So CAP stands for consistency, availability, and partitioning. I think it is partition tolerance. It's called partition tolerance. Yeah, partition tolerance. So we'll discuss what this means. Okay. So any distributed system. So if I go back to here and draw the same diagram again, right? Let's say I have a system. There's a database. I have 4 of these here. Cool. So now, so all of them are connected with each other through a wire. So then there are 3 properties: consistency, availability, and have TITI and partition tolerance. Okay. So what does consistency mean? That whatever is the data across all of them, no, it is always same. It is always accurate. So there is a topic called as replication. So what replication means is same data is stored across it happens in NoSQL databases where same data now you store across you store 2-3 copies of the same data so that it is very easy to fetch. Let's say I have a database. Let's say it's called books database. So what I'll do is I'll put this across all 4 databases. Books is here also, books is here also, and books is here also. So this way, what happens if anybody comes to ask to read from books, right? So I can give them from any database in this whole connection. That way, what is happening? They're able to get the data very fast because let's say if 1 million people are accessing this table, I can send another million people to this, another million people to this, another million people to this. Correct? So we replicate data across databases so as to fetch data fast and it becomes very quick to get data because let's say I have this database in India, this is in US, this is in India, US, this is in Europe, this is in Australia. So for somebody who is in USA, if I tell them to go access data that is there in India, USA India difference is only how many kilometers? I think it will be in some 1,000 kilometers, 30,000, 40,000 kilometers. Or is it even more or less? I don't exactly know the distance, but even for light to travel that much, it will take certain milliseconds. So light travels at a speed of 3 lakh per second, right? So if it is 30,000, 40,000, it will minimum take you 100 millisecond to sit in US, open your computer, hit Indian database, and then go back. So I'm just wasting 200 milliseconds to get the data. No processing, nothing. Just go, touch, and come back. It is like relay, touch and back. No, so just to touch and back, I'm taking 200 milliseconds. So it doesn't make sense to do that. What is much more sensible? So if somebody is coming from US, tell them to go to the database in US only. Right? So here I have stored a copy of whatever the same data. I'm storing a copy of it everywhere. So that way, what is happening? So this person will go hit the US database only. It will be what? Let's say 100 kilometers away. So to fetch something which is 100 kilometers away, let's say 1,000 versus 30,000, lot of difference, right? So 30,000 was taking 100 milliseconds. Now it will take you 30 millisecond or 40 millisecond, right? So that is why we always try to store data, which is data, and we use all the companies, right? Let's say for YouTube and all, no? So they store the data that is near whatever data, right, in your nearest data center or nearest to you only. So when you request for something, you get it from the nearest data center or nearest caching server, or let's say CDN. Okay, that apart. So now, if that is the situation, then there are few things that can happen. So let us say I was sitting in India, and then I updated the. Let's say there was some value T, and everywhere T was there, and I updated T was 10, 10, 10, and 10. Okay, so now I updated T's value to 11. Okay, so now they should also propagate to all other people, right? So I have updated the value. It should not just because I've updated it, it should always go to all these people. Correct. So to do this, now there are two possible ways I can follow. One is I will to me who is sitting in India, what the server can do is it can update this to 11 and it can tell me I have updated to 11, but others will get updated in some amount of time, or it will send a message to everyone. You get updated to 11, you get updated to 11, you get updated to 11. Okay, so this is one way, or the other way is when I tell it to update to 11, no, what it will do, it will send messages to everyone first, update to 11, update to 11, update to 11. And whenever this say that I have updated to 11, no, and it has also updated to 11, only once all of these people say it has become 11, no, it will tell me back that, okay, your value is updated. Okay, so there are two things happening here. In first case, what was happening? the database was updating first, and then the database was telling me updated first, and then going and updating the other databases. But in the second case, it was ensuring that all of them are updated and then giving me the value. Correct? So in first case, what is it doing is it is trying to achieve availability. Okay, I wouldn't consider this availability bit. But in second case, it is trying to achieve consistency, real-time consistency, right? In first case, it is eventual consistency, and in second case, it is real-time consistency. Agreed with me? Yes, right. So in the first time, it is slowly and slowly syncing all the values to other databases, but in the second time, it is waiting till all the databases become one value, and then it is telling me back, okay, your update is successful. Okay, so this is related to consistency. So what CAP theorem says is you can only have partition tolerances provided if the network is not breaking. So the network can be, it can get cut anytime, right? So assuming the network doesn't get cut, you can only have either full availability or full consistency. You cannot have both. Take a little bit time to digest the idea. So what it means is with partition tolerance, by partition tolerance, I mean, even if there is some network that is going down, I can only achieve either availability or consistency. I cannot have both availability and consistency. Why? Because if I want to have availability, at least if 2, 3 are out of this 4, even if 1 or 2 is available, it is okay for me. But I cannot be consistent because I don't know what these other 2 have the data, right? But if I want to have consistency, I can't have availability all the time, because let's say 1 or 2 were down, and then I sent it a request saying update T to 12. So it will say not available. Why? Because 2 of the nodes are down, and because 2 of the nodes are down, it won't update. So it means it is not available, but it is consistent. So considering partition tolerance means any one of these nodes going down, you can either have full availability or you can have full consistency. You cannot have both availability and consistency. Okay, let's go through the definition once, maybe. Thinking you guys are not clear. So consistency means every read receives the most recent write or an error. So that is what I meant here. When I updated 11 here, no? So all of these 3 should also receive 11, or they should receive an error saying, or I should receive an error saying update is not done. Okay, so that is consistency. Availability means every request receives a response without guarantee that it is the most recent. So when I updated 10 to 11 here, and let's say somebody in Europe queried the value, they got 10 as the value. So it is not guaranteed that 10 is the latest value only. 10 can be slightly older because the database is not synced properly. Right? So that is that. And partition tolerances, the system will run even when network partitions occur. Network partition means there is failure between connecting to any of these nodes with one another. So even when such thing happen, your system is still running. Okay. Standing consistency. It is the same, repeat the same thing. Consistency means every read operation returns the most recent. Availability means sorry, we missed availability. Availability is here. Available system. In availability system, in any case, you'll get a response. That response can be very accurate or slightly old, but you'll get a response. Okay. So we talked about trade-offs, right? So the trade-offs are so you can achieve consistency and availability at the expense of partition tolerance. This usually doesn't happen. These are the 2 main things. One is availability and partition can be achieved at the expense of consistency. So you can have partition tolerance and availability if you don't want consistency. If you want consistency and partition tolerance, then you cannot have availability. Okay, it's like you can only have 2 of the 3 at any point in time. You cannot have all the 3. Okay. So example is fine. So these are different NoSQL databases, and see, Google Big Table achieves partition tolerance and availability, but it is okay with being inconsistent. DynamoDB achieves partition tolerance and availability, but it is okay with being inconsistent. MongoDB is consistent in partition tolerance, but it can sacrifice availability for some time. Okay, so all real life examples you can put here: Twitter, Instagram, YouTube, where you are not seeing likes frequently, right? Like if you do a like, you won't see the like just then and there itself, because they are they want to be highly available and have partition tolerance, but they don't necessarily want to be what is it? They don't necessarily want to be consistent. But if you take a banking, if you take UPI, UPI will never be inconsistent. UPI may not be highly available. Sometimes UPI can go down, but it will always be consistent. If you check your balance now and if you check your balance just after, let's say if you check your balance now in India and you go to US and check your balance via UPI, it will still be same. But it can happen that sometimes UPI is down because UPI want consistency more than availability. Okay. So depending on the use case, there are some use cases where you would want consistency, and there are some use cases where you would want availability. So now this is not just for databases; it is for any system also. Any distributed system, CAP theorem is applicable. You can have only two. You can't have all the two. Okay, that's it. I think that much only. So I think we have covered most of the topics that are necessary to understand databases and how databases work, what are different kind of queries in database and all. Okay, I hope you guys were able to understand. It was helpful. I thought I'll cover interview questions, but I'll share the links with you people. I think you can go through the links. Okay. So, any doubts, any feedback, anything you guys want to share? I won't be available after this class. So, good feedback, bad feedback, that is also welcome. Or you felt anything still that could have been covered, that is also welcome. Or if you have any doubts, that is also welcome. Who wants to go first?
Sir, which one is the more consistent, sir? NoSQL or SQL database?
SQL databases are by default consistent.
Okay. So why that CAF theorem we have included with NoSQL? What does mean that?
Because NoSQL databases are distributed, right? So horizontal scaling is there. So a
Yes.
database is spread across 3-4 systems. So when the database is spread across 3-4 systems, there is possibility of a disconnection happening between one of those systems, right? So when a disconnection happens, do you want to give preference for availability, or do you want to give preference for consistency? So if you want to give preference for availability, that time what you will do? Okay, so this system is down, but I am able to access other 3 systems. I'll get the data from that system. Okay, but if you want consistency, what you will do? You will say this update is not going to happen only because one system is down. I can't take this update. So by doing that, what is the system behaving at? The system is behaving consistently.
Okay, sir. And sir, which database is more used in industry for web application development or deployment, etc.?
It depends on the use case. I told you, no. So let's say you are a bank, or you are some place. So where I work, no. So we have used a combination of both. So we have used SQL, we have used NoSQL. Let's say to store user data, right? We used to use a SQL, but to store things like, let's say, billing related information, or let's say you want to store user preferences, or you want to store uh, details related to an order and all. There we used to store it in a NoSQL database.
So now we have studied SQL databases fully. So it is a need to learn the databases like MongoDB for interviews also?
No, not
Full,
necessary. Not
uh,
necessary. Whenever this much of whatever we have discussed, no, that much of knowledge about NoSQL is enough. So because it is not consistent across the NoSQL databases, right? So different NoSQL database have different language to talk to them, but the ideas remain the same. They are unstructured or semi-structured. They are highly available. You can partition them. They support horizontal scaling. Those all points remain the same. So Kaniraj, did you understand everything whatever was taught in all the 18 sessions, or you have somewhere you felt we could have improved? Are you there, Kaniraj?
Yes, Guru. Sorry.
No, I was saying, yeah. Do you felt anywhere we could have done better?
Um, the practical way was really good actually. What I expected it was really out of bound actually. The only one thing I feels to improve in this session is while coming to the paint part, right?
Mm-hmm.
Uh, it will be much more better to uh, write it in a good way. Like it's not so looks clear. Yeah.
It's not readable. It's not readable. Okay, I get it because I'm too much in a flow, so I start moving my pen so
Yes,
fast.
actually, it will be like a notes. We will at the running time we will take a notes now. It's kind
Yeah,
of
yeah, yeah.
yeah. That's it.
Yeah. Okay, I get it. Point taken.
Yeah, yeah. That's it. Apart from that, everything is good. Concept covering everything is really good. Yeah.
Yeah, we've tried to cover most things that would have been taught in the college uh, syllabus for DBMS. And the structure was also like that only. What about you, Suraj?
Yes, sir, everything is well, sir.
Okay.
Now it's time to revise all the things time to time to memorize everything.
You don't have to memorize. I wouldn't suggest you to memorize. But if you understood the concepts
Yes,
right,
understood. Your
yeah,
concept
it is
understood.
it is more of like doing a Google search. How to write. So even that is why I was not hesitating to search during the classes. So it's okay. We are human. So sometimes you might forget where to put a for or where to put a to. It is fine. You can
Yes,
just
sir. Mhm.
quickly look up. So you should not hesitate doing that.
Yes, sir. So can we do a project by using MySQL?
Yeah, when they teach you Java and all, right? So in the backend you'll be using MySQL.
Okay, okay. Yeah, apart from that, whatever you have taught in practical session, we need to like know the syntax and everything.
Mm-hmm. Yeah, that is there. That is
That
there.
is sufficient. That is sufficient for uh, using backend with
Yeah,
MySQL, right?
yeah, that is sufficient. Yeah, it's sufficient enough.
Mhm. Okay, sir.
Okay, Rishikesh, you have something?
yes sir, everything was great sir. मैंने अपने कॉलेज में भी इतना नहीं सीखा था डेटाबेस के बारे में. मतलब एक सेमिस्टर में था, मतलब पूरा 4 मंथ के सेमिस्टर में, पर वो बहुत लो लेवल पे पढ़ाया था उन्होंने. सो दिस कोर्स वाज रियली हेल्पफुल फॉर मी, सो फॉर अंडरस्टैंडिंग डेटाबेसेस. सो थैंक यू सो मच फॉर टीचिंग अस.
Thank you. That's fine. Sushant, I'm seeing who all were all active phases in all the classes. I think all of you attended most. Sushant is there.
Yeah, good. Uh,
So
So,
what you did not understand, or
no,
what
sir.
you need to revise more
Yeah,
still?
yeah, I understand what you teach.
I think probably today's class was a bit fast paced because I had a lot to cover.
Yeah,
That I take it, but the PPTs and all, they're self-explanatory. If you have a look, or even if not, you can search online these topics. There are a lot of videos on them that you can understand.
yeah, sure.
Okay, okay, cool then. So if you guys don't have anything, I'll share this this PPT also with you guys, and I had certain links that I wanted to share. I'll share those also.
Guru, can you send the interview question?
Yeah, I'll send. So even I, I was searching online. So where would I get good ones? Same. I don't. I won't be sitting and creating. No, I'll also look from one. I'll pick up few websites. If I find PDF and all, also I'll send it.
Okay, okay.